Hello everyone, welcome to Dennis Simplifies. In this lesson, we are going to learn how to use the mesh analysis to find the current in a resistor in a circuit. So, let's simplify. In this circuit problem, we have two voltage sources and then we have three resistors in a loop. Now, we have three loops here. This is one big loop, another loop here, another loop here. Now we know that a mesh is within a loop, so we have mesh 1 here and then mesh 2 here, but we have three loops. Okay, so now that we know our loops, in mesh analysis we deal with each loop at a time. So we deal with each mesh at a time. So we take mesh 1 here, we solve for mesh 1, then we take mesh 2, and then we solve for mesh 2. So now let's assign our signs. Let's do our sign conventions. So looking at the voltage source in mesh 1, which is 42 volts, we have a negative here and we have a positive here. Okay, so now let's take the direction of our current to be going in the clockwise direction. And let's call our current I1. So we call our current I1. Okay, so we've assigned the signs over here, we've done our conventions here, negative and then positive. Now be reminded that current always enters a resistor conventionally from the positive side to the negative side. The same thing, current always conventionally enters a resistor from the positive side to the negative side. Okay, so now that we've done our conventions, so what we say is that whenever you have the current, which is I1, moving from the negative to the positive, we say we have a voltage rise. When you have the current moving from the positive to the negative, we have what we call a voltage drop. The same thing here, when the current moves from the positive to the negative, we have a voltage drop. So now that we know our voltage rise, our voltage drop, and another voltage drop here, we can go on to write our Kvl equations. The Kvl equations are what we call the Kvl voltage law equations. According to the Kvl voltage law, the algebraic sum of all the voltages in a circuit should be equal to 0. So when we have a rise here plus a drop here plus another drop over here should be equal to 0. So let's write our Kvl voltage law equations. So we are taking it from the 42 volts. So we have 42, which is a rise making in the positive. We have 42. Then our 6 ohm, we have a drop because the current is moving from the positive to the negative, and we have I1 going through that. So a drop will be a negative 6, and the current going through the 6 ohm resistor is I1. Now let's go to our 3 ohm resistor. This 3 ohm resistor is a special case. Why? It has two currents going through it. The current from mesh 2, which is I2, and I1 are all going through this 3 ohm resistor. But you know that whenever the current is moving from the positive side to the negative side of the resistor, we have a voltage drop. If we've concluded on that already. So we have -3. So what you have to do now is to find the current that is going through this 3 ohm resistor. Anytime you have two currents going through a particular resistor which is shared by two meshes, whenever you want to find the current going through it, it is always the current from the top minus the current from the bottom. So the current from the top in this case is I1. We know that I1 is coming this way and I2 is coming that way. So the current from the top minus the current from the bottom. So we have I1 minus I2. So I1 minus I2. So now that we know this, according to the Kirchhoff voltage law, the algebraic sum of all the voltages in a circuit should be equal to 0. So what we have here is just simple algebra. We are not going to go through that. So when you simplify, you are going to have your first equation for mesh 1 to be 9I1 minus 3I2 being equal to 42. So that's our equation 1 for mesh 1. So we call this our equation 1. So now let's move on to mesh 2. In mesh 2, we have I1 moving in the clockwise direction. So let's do our sign conventions. We've already assigned the 3 ohm resistor, and we've already assigned the 3 ohm resistor, which is negative here and then a positive over here. And then let's come to our 4 ohm resistor. We said that the current conventionally enters a resistor from the positive side to the negative side. So we can assign our 4 ohm resistor here to be plus and then a minus here. Okay, so when we look at our voltage here, it already has its signs, negative and positive, so we can put that one down too. So we have negative here and then positive over there. Okay, so we know that whenever you are moving, a current is moving from the negative side to the positive side, we have a voltage rise. So the voltage is rising from the negative to the positive. We have a voltage rise. Now when you go to the 4 ohm resistor, we have the current moving from the positive to the negative. So in this case, we have a voltage drop. Okay, now when we come here to our 10 volt, our voltage source here, it is negative to positive. So when the current is moving here, it moves from the negative side to the positive side, and then we have a voltage rise. Okay, so now that we know our voltage rise and our voltage drops, we can write our Kvl equation, that's the Kirchhoff voltage law equations for mesh 2. Now before we write our equations, let us remind ourselves that in mesh 1, this 3 ohm resistor had a voltage drop because I1 was moving from the positive side to the negative side. But in mesh 2, I2 was moving from the negative side to the positive side. So we have a voltage rise in mesh 2. Let us always note that. Okay, so now let's write our Kvl equations for mesh 2. So we have a voltage rise in our 3 ohm resistor. So that will be a positive 3. We know that the current going through our 3 ohm resistor is I1 minus I2, because we said whenever you have a resistor being shared by 2 meshes, the current moving through it is the current from the top minus the current from the bottom, which we have done over here. So you can just copy it over here. So which is I1 minus I2. I2, my I looks like a J. Let's clean that up. Okay, so I2 here, and we close it. So we go to our 4 ohm resistor. With this one, we said it's what a voltage drop. So a voltage drop will be a minus. So we have a minus 4 ohm, and the current going through this 4 ohm resistor, the current going to the 4 ohm is I2 only I2. The 4 ohm resistor is not shared with any other mesh, just mesh 2. So the current going to the 4 ohm resistor is just I2 only. So I2 for the 4 ohm resistor. Then we go to our voltage source, the 10 volts over here. The current is moving from the negative to the positive. So again, we have a voltage rise. So that will be a positive. A voltage rise. A rise is a positive. So we have plus 10, 10. And then according to our Kirchhoff voltage laws, we know that the algebraic sum of all the voltages in a circuit should be equal to 0. Okay, so now we can simplify this by simple algebra. We can do that, and we have equation 2 to be 3. You can pause the video and try it by yourself. You have 3i1 minus 7i2 being equal to negative 10. Okay, so now we have our second Kvl equation. So we can solve for I1 and I2 simultaneously to find I1 and I2, of course. So we are not going to go through that. When you do your calculations right, which I'll encourage you to pause the video and then try solving for I1 and I2. When you do it right, you are going to have I1 to be equal to 6 amperes. You know, the unit for current is amperes. And then I2 to be equal to 4 amperes. And then if you want to know the current through our 3 ohm resistor, which was I1 minus I2, then we are going to find the current in that resistor to be 2 amperes. Since it's 6 minus 4, we get 2 amperes for the 3 ohm resistor. Okay, so we are done. Now let's try some questions. Let's try our next question to see how well we fare. Okay, so in this circuit problem, this one we have 3 meshes instead of 2 meshes. The one we solved before had 2 meshes. In this one we have 3 meshes. I will encourage us to pause the video and do our sign conventions. Try to assign try to do the sign conventions on this, and then let's see how it goes. Okay, so let's start from mesh 1. This is mesh 1, this one is mesh 2, and that is mesh 3. So in mesh 1, let's assign our conventions. Okay, so I1 is moving in a clockwise direction already. So we have here, we said that conventionally the current enters from the positive side to the negative side. When you look at this 3 volt voltage source over here, we have our positive first and then our negative first. Ask me why. Why? Because we have the bar on top being longer than the bar beneath, meaning that the plus is on top and then the minus is below. Okay, so now we come to our 9 volts, our 9 ohm resistor. The same thing, we have our plus here and then our minus at the other side. Same thing here, our plus here and our minus here. So we are done doing our sign conventions for mesh 1. So this is our sign conventions for mesh 1. Since we know this, we can, based on this, to write our Kvl equations. So now let's write our Kvl equations for mesh 1. Okay, so let's talk a little about voltage rise and our voltage drops. In the 4 ohm resistor, since the current is moved from the positive to the negative, we have a voltage drop across it. And then when we come to our 9 volts voltage source, the current is moved from the positive to the negative. Again, we have a voltage drop. Now we come to our next one, our 9 ohm resistor. Remember, the 9 ohm resistor is shared by both mesh 3 and mesh 1. So our voltage, the drop here is going to be, the current is moved from the positive to the negative. I1 is moving from positive to negative, so we have a voltage drop again. In the 3 ohm resistor again, I1 is moving from the positive to the negative, so we have a voltage drop again. And be reminded that I1 and also I2 flows through this 3 ohm resistor. So now let's write our Kvl equations, that is our Kirchhoff voltage laws. So we know that the algebraic sum of all of this should be equal to 0. So now let's write our first equation. I will encourage you to pause the video and then try writing out the equation. Okay, so now let's write it out. Since the 4 ohm resistor is a voltage drop, we have a minus 4 ohm, and the current going through it is I1. We have I1 going through it. Then we go to our voltage source, which is the 3 volts. There's another voltage drop across it, so we have 3 volts over there. We come to our 9 ohm resistor, we have another voltage drop over there, so we have 9. Remember that both I1 and I3 are going through the 9 volt resistor, and we say whenever you have 2 currents going through the same resistor, it's the current from the top minus the current from the bottom. In this case, we have I1 coming from the top, so we have I1 minus I3. I1 minus I3. So we move on to the next one, our 3 ohm resistor, another voltage drop, so a minus, we have 3, then the current going through the 3 ohm resistor will be I1 minus I2, because I1 is coming from the top, and then I1 is coming from the top this way, and then I2 is coming from the bottom, so you have I1 minus I2. I1 minus I2. So you have I1 minus I2. Now, according to the Kirchhoff voltage laws, we can have this equal to 0, because according to the Kirchhoff voltage law, the algebraic sum of all the voltages in the circuit should be equal to 0. In the mesh analysis, we solve one mesh at a time. So we are done with the first mesh. When we simplify this, we are going to have negative 16 I1 negative 16 I1 plus 3I2 plus 9I3 being equal to 3. That is when it is simplified. So here we have our first Kvl equation. Okay, so now let's move to mesh 2. Okay, so let's move to mesh 2. In mesh 2, let's do our sign conventions. So over here, I2 is moving in a clockwise direction, and we have the bar on top being longer than the one beneath for the 10 volts. For this one, so this one will be a positive and a negative. So because the bar on top is longer, so we have positive and then a negative. Now since I2 is moving in a clockwise direction, it's conventionally going to enter the positive side. No, we won't do that one yet. I'll explain later. So for the 9 volts, the same thing, the bar on top is longer, so you have a plus here and then a negative here. Then here to the same thing, the current is moving through the positive side, so you have a plus here and then a negative here. I didn't do the conventions for the 3 ohm this one because we've already assigned it. Remember, when we're doing the mesh 1, we assigned here to be positive, here to be negative. So whenever you're doing for a different mesh, you don't give it a different sign convention. You use the one you used before for the same mesh. Okay, so now that we know our sign conventions, we can see that for the 10 volts we have a voltage rise, for the 3 ohm we have a voltage drop, for the 9 volts we have a voltage drop again, and then for the 2 ohm we have another voltage drop. So with this, we know the algebraic sum should be 0, so we can write our Kvl equations. So we have a rise, which is 10 for mesh 2, a 10, and then we have a drop. Sorry, we have a rise, which is for the 3 ohm. For this 3 ohm we have a rise because we're moving from the positive to the negative. Remember, when we're doing mesh 1, we had a voltage drop, but when we are doing for mesh 2, this time we are moving from the negative to the positive. In mesh 1 we moved from the positive to the negative, so we had a drop. In mesh 2 we are moving from the negative to the positive, so we have a rise in voltage. So in the 3 ohm resistor, this time we have a rise, which should be a positive 3, a rise in voltage, and the current, we found the current going through that one already. We said that when the current coming from the top minus the current from the bottom, so we have that here, which is I1 minus I2. So we just copy that one there, I1 minus I2. Okay, so now let's move to our 9 volts here. This 9 volt, the current I2 going through it, the current going through I2 would be the current going through this 9 volts, so it's moving from the positive side to the negative side, so you're going to have a drop in voltage. Alright, so a drop in voltage will mean a negative, so you have negative 9 over here. Okay, then we move to our 2 ohm resistor. This 2 ohm resistor, we have another drop in voltage, a positive and a negative. The current moves from positive to the negative, so we have another voltage drop, so another minus here, minus 2. Okay, now since it's a resistor, the current going through that will be I2 will be going through the 2 ohm. I2 will be going through this 2 ohm resistor, so we have that over here. Since we are done with mesh 2, and according to the Kvl equations, the algebraic sum is always equal to 0. So we can simplify this, and then we'll have second Kvl equation to be 3I1. You can pause the video and try it on by yourself and see what you also get. 3I minus 5I2 equals -1. So this will be our second Kvl equation, our second Kirchhoff voltage law equation. So now we can move to mesh 3. In mesh 3, we have this voltage over here being shared between the two of them. We've already assigned it to be negative and positive. We have this 9 ohm over here. We've already assigned it to be negative and positive over here. Then we have our 1 ohm resistor over here. So the current I3 is moving in a clockwise direction. So it is moving in a clockwise. So here will be positive. So it will move. It will enter the 1 ohm resistor from the positive side to the negative side. Then this voltage source here, as we know, will be negative here and then positive over there. So since we know our sign conventions, let's talk about our voltage rise and our voltage drops. Okay, so in this we are going to have a voltage rise from the 9 volts. From this voltage source we are going to have a voltage rise. Then from here, negative to positive will be a voltage drop. Remember that, sorry, a voltage rise. Remember that when we were doing mesh 1, we had a voltage drop. But in mesh 2, we are now moving from I3 is moving from the negative to the positive, so we have a voltage rise. Then when you come to the 9 ohm resistor, we also have another voltage drop. Since the current will be moving from the positive to the negative, we have a voltage drop. Then we come to the 14 volts. It's negative and positive, and the current is moving in the clockwise direction, so we have another voltage rise. Okay, so we can write our Kvl voltage law equations. Since we know our rise and falls, and we know that the algebraic sum should be equal to 0, so we start from the 9 volts. So we have 9 plus the 9 ohm resistor, and we know the current through that one will be, we said whenever you have a resistor being shared, the current going through it is the current from the top minus the current from the bottom. We have I1 coming from the top and I3 from the bottom, so it will be 9 brackets I1 minus I3. We have that over here, you can see that, so we don't change our conventions. It's I1 minus I3. Okay, so we move to the next one, which is the 1 ohm. This 1 ohm resistor, we have a voltage drop. So when we have a voltage drop, it's a minus. So we have minus 1, right? And we know 1, we can ignore that. And the current going through it is I3. So you have I3 going to our 1 ohm resistor. We can set that to 0. Sorry, there is one more, which is the 14. There is one more, our 14. So the 14 is for a voltage rise, since it's from negative to positive. So you have plus 14. Now we are done, we can set it to 0. So from this we can derive our third Kvl equation. Let me write it over here. So let me write it at the top there. I'm writing our third equation over here. So our third equation, we are going to have, when you simplify it, you have 9I1 minus 10. This is algebra. You should try it and see. Simple algebra. 9I1 minus I3 equals negative 23. Okay, so this will be our equation 3. Okay, we know that this will be our equation 3. So when you solve equation 1, when you solve this, our equation 1, equation 2, and then equation 3 simultaneously, we are not going to go through that. When you solve them simultaneously, which I will encourage you to pause the video and then try using either your calculator or working manually to find I1, I2, and then I3. Okay, so if you do it right, you are going to have I1 to be equal to, you have I1 to be, you have I1 to be 3 amperes. I2 to be 2, and then I3 to be 5. Okay, so that's it for the mesh analysis. If you have any further questions, you can leave it in the comment section. If you like this video, please like and share, and if you haven't yet, please subscribe for more videos on the next one, which will be on the Thevenin and the Norton's theorem, which there is more to do on that. So thank you for your time, and then do all to subscribe if you haven't, and then leave your answers or any questions or any other way you solve this. Leave it in the comment section so that let's discuss what we just did. Thank you.